So now we're going to be looking at manganese, nickel, and cobalt chemistry. Most of this video will just be reactions that we're going to be revising through. I'm not going to be going too much into the reactions, it's just revision for the reactions. So we're just going to be going through those, and that's all. So first we're going to be looking at cobalt, and again everything is pretty similar. We're going to have cobalt that's going to be reacting when we add a little bit of NaOH, and we're going to be getting your blue precipitate with cobalt, and this is going to be a deprotonation acid-base reaction. Okay, and then if you add H plus, it can go the other way around as well. So you can add H plus, and we'll go from the blue precipitate to the pink solution. So pink solution here, and we have the blue precipitate. So we've seen these reactions a lot, and I'm sure you're familiar with this as well. I hope so. And the same thing happens when we add a few drops of ammonia as well. Same thing again. All we want to do is remove this charge. On zero charge, we're going to have a PPT, pink solution to blue PPT. By the way, nothing happens when we add excess NaOH. Nothing, okay? So nothing happens when we add excess NaOH. The only transition metal element that reacts with NaOH, excess NaOH, is just zinc. That's it. The rest of them don't. Right? So then we have again cobalt again, dihydroxo tetra aqua cobalt, and that's a blue precipitate. We're gonna add excess ammonia, so we're gonna have 6 ammonia ligands, and they're gonna replace the water and the hydroxo ligands or hydroxide ligands, and we're gonna have a ligand exchange occurring. So the first one is deprotonation, this one is ligand exchange, and we're gonna go from blue precipitate to a yellow solution. Okay, a yellow and light brownish solution, and this is gonna be ligand exchange, right? And the reason why I'm writing all these equations is because they want you to know the colors, but they also ask you the equations in exam. Okay, and then remember, you can take this blue precipitate, and what you can do with this blue precipitate is you can leave it in air for it to oxidize. So the cobalt will become from cobalt 2 plus, so it's gonna have cobalt 2 plus to cobalt 3 plus. So to balance that, to make sure the charge remains 0, we're gonna have one more hydroxide here with one more minus. So we have 3 minus here and 3 plus there, so there's no charge. And then here we had plus 2 and we had minus 2. So to balance it out, we had one more hydroxide there as well. Okay, and then if you want to take the yellow solution here that has 6 ammonia ligands, and you want to oxidize the cobalt again, then we just leave it in air, and you see it goes from plus 2 to plus 3. So cobalt is going to be oxidized. So it goes from blue precipitate here to brown precipitate, and yellow solution to brown solution, right? So you can take this thing right over here and oxidize it from yellow solution to brown, and you can take this precipitate and this precipitate, both of them are same thing, and you can oxidize it further as well. Okay, that's basically cobalt. Now we have tetrachlorocobalt, which is going to be blue solution, and if we add 6 water ligands, it's going to form our hexa aqua cobalt with our 4 chloride ligands that are going to be replaced, and your hexa aqua cobalt is going to be a pink solution, right? And your tetrachlorocobalt will actually be a blue solution. I think I've written that, yeah, blue solution. And this reaction can go the other way around. If you have hexa aqua copper and you add concentrated HCl to it, something that has Cl minus in it, so HCl would be good. So you add concentrated Cl minus, and you react it with your hexa aqua copper, and you're gonna get back to tetrachlorocobalt. Alright, we've already discussed why only 4 chloride ligands are there, because chloride ligands are very big. Okay, Alright, now we're going to talking about nickel. So nickel, again, nothing happens in excess. We're going to have deprotonation as the first reaction. So we're going to go from a green solution to a green precipitate. Everything is the same here, nothing very unique here. So, and then we have nickel again with ammonia, same thing, green solution to green precipitate. This is going to be deprotonation. With excess NH3, it does react further. So we go from a green precipitate to a blue solution. So again, the same thing that happened with cobalt. We have 6 ammonia ligands that are going to be replacing the water and the hydroxide, and we're going to have ligand exchange happening. And notice that this precipitate here that we have, it can both react with, give me a second, it can react with H plus to go this way, right? And it can also react with NH3, which is a base. So it can react with both acid and base. So it shows amphoteric behavior as well, right? And this reaction here is ligand exchange. Okay. So again, green precipitate to blue solution. So this has been asked as a 6 marker as well. All of these reactions, you have to write it down, and you have to state, okay, this is deprotonation. This is deprotonation. Nothing happens when you add excess NaOH, and then this is ligand exchange. So that was a 6 marker, so learn this as well. The final one again is going to be manganese, and we have our reactions here for manganese. So manganese is going to undergo deprotonation only, no ligand exchange. It doesn't react with excess NaOH or excess NH3. It only reacts with when you add a little bit of NaOH or ammonia. So again, it's a very similar reaction that we have seen so far. It's very repetitive. You only have to remember the colors. I think the amount of reactions you have seen by now, it should be really, really repetitive. So you go from pale pink to light brown, and then we go from pale pink solution to light brown precipitate, PPT, precipitate, okay? And this was our deprotonation reactions, okay? Now, what you can do is you can take the precipitate and you can leave it in, you can leave the solution in air with the precipitate, and the manganese will be oxidized from +2 to +3. So notice, +2, -2, so it's going to have a charge of 0, right? And then we have +3 here, and we have -3 here, right? So it goes from +2 to +3. So now we're going to be looking at the reactions of manganese. Again, we have, now manganese, it only reacts with a few drops of sodium hydroxide and ammonia. It doesn't react with excess sodium hydroxide or ammonia, so it doesn't undergo ligand exchange or display any of the amphoteric properties that we have seen. It only undergoes the deprotonation acid-base reactions. Okay. So again, the same thing with just the difference of here being the OH minus and here being the ammonia, right? The rest of the equations are basically the same. You're just going to get rid of the charge by deprotonation, and then you're going to have the precipitate being formed. So we have seen this a few times now. You have the pale pink solution, goes light brown, pale pink solution, goes to light brown, precipitate. Okay, precipitate. Alright, now you can take this precipitate that's there and you can leave it in air and it'll get oxidized. Let me just put the 2 here. Yeah, so it'll get oxidized from +2 to +3. That's why I noticed we have 3 hydroxides here, right? And then above we had only 2. Just to balance it out, right? So -3 +3 and +2 -2. Okay? Right, so this was just a quick revision on this. And yeah, that's all for this.